Yeah, namaste everyone. So we are going to start with motion. It is one of the chapters in physics. Now, in your day-to-day life, you would have seen a lot of objects, like for example, tree, poles on the road, and so many other objects which are stationary. That means they're fixed at one point. On the other hand, there are so many other objects like car or even we as human. Like when I'm teaching, I'm moving my hand. Like vehicles. So on one hand, there are some objects which are actually at one point, they're stationary. On the other, some objects are in motion or movement. So whenever there is movement of an object, we say that there is motion. So motion means there is movement. And whenever there is movement, there is also time associated with that. Okay. So it takes some time to move my hand from here to here. It takes some time, maybe 1 second. But definitely it takes some time to move my hand from here to here. So whenever the position of any object, here I have my hand is moving from here to here. Whenever the position of any object changes with respect to some time, we say that the object is in motion. For example, I have a car, like this, assume this is a road, okay? Assume this is a road. Okay, this is a road. So generally, if you have any surface on the earth, we actually mark it like this in physics. Okay, we mark it like this. Suppose I have a car here, which is at point maybe A. There is a car here, okay? This is at point A, there is a car. After some time, the car has come to this position. Let this be B. The same car has come to this position B. So if you look carefully, the position of the car has changed from A to B. Position means it has moved some distance. So the position, maybe this is 10 meters, for example. So the position of the car has changed, or maybe like I'll take some maybe 1 kilometer. So the position of the car has changed from A to B in some time. It has taken some time for the car to move. So we can say that the car is in motion. So any object, whenever it is changing its position with respect to some time, we say that the object is in motion. Okay, so how do we define motion? I'll define it like this. Motion means, I can define motion like this. Whenever the position of the object changes with respect to time, we say that the object is in motion. Okay. Now, whenever we are defining any motion, whenever any object is moving, whenever we are defining any motion, we need something called as a reference point. Okay, a reference point. What is a reference point? See, reference point basically helps us to locate any object. See, suppose I want to visit my friend's home. Only if I have a reference point, I will be able to go to my friend's home. Otherwise, I will not. For example, if I want to visit my friend's home, I should know where to get down, which bus stop to get down. Okay, if I'm going by, if I'm traveling by bus, I should know which bus stop to get down. After getting down from the bus, I should also know, like from there, which location should I go? Whether should I take left, right, where should I go? So like my friend would have told, like after getting down at the bus stop, take a left and there'll be a bank. So basically he's defining some reference points. So what is the use of a reference point? A reference point basically helps to locate any object. Okay. So what is the use of a reference point? It helps to A reference point helps to locate an object. Okay. Now, moving forward, we are going to learn another concept, that is distance and displacement. Okay. And through that, we'll actually learn few more concepts. Okay. So let's learn about distance. What do we mean by distance and displacement? See, generally people think both are the same thing, but in physics, they are different, totally different. Distance and displacement, both are totally different. Okay. Let's assume I want to go to my friend's home. Okay. Suppose I am at this point A. Let it be actually I'm at this point A, and I want to go to my friend's home who is at C. I want to go to my friend's home. Now, actually, I get another call to visit another friend of mine who is at actually another location, maybe at actually, you can say maybe at B. Okay. Or you can take maybe like my friend is here also. Like you can take it anywhere. Okay. See, I had decided that I want to visit my friend who is at C. C means some location you just keep in your mind. Okay. Let me put it in a straight line. Actually, it'll be easy for me. So I'm at A and I want to go to my friend's home, who is at actually C. But in the middle of that, I get another call that I need to actually go to also meet my friends who is actually at B. So what I do is, maybe because of some urgency, I have to actually first of all meet my friend at B. So actually I go to my friend's home at B. So I go like this. I'm putting my dotted line. Okay. First of all, I go to my friend's home at B. Okay. And after meeting my friend at B, I go to my friend who is actually at C. So if you look carefully, how am I traveling? First of all, I'm starting from this point, going to my friend's home at B. And after meeting my friend at B, I'm also going to my friend at C. So I've traveled from A to B, B to C. Okay. Maybe the distance between my home and my friend's home, who is actually at B, be maybe 2 kilometers. Okay. The distance between, or maybe I'll take 5 kilometers. Okay. And the distance between my friend B's home and C's home, let it be 3 kilometers. So if you look carefully, I have traveled first from A to B and then from B to C. So the total length which I have traveled, the total path length traveled by any body, I am the body here, actually I am traveling. The total path length covered by any object or any body, that is referred to as distance. Distance means what is the length of the path traveled by the body. So the body is going from A to B and B to C. So AB plus BC, that will be the distance. Then what is displacement? So first let me write the definition of distance. So distance means the total path length covered by an object or by a body also you can write. Okay. Don't write anything during the lecture. Just listen, understand. If you have some doubt, do let me know. We'll discuss. So here, if you look carefully, distance covered will be, in this particular example which I gave, distance covered will be what? AB plus BC. Now, what is displacement in physics? In physics, displacement means the shortest distance between the initial point and the final point. See, I started from point A And right now I'm in point C. The shortest distance between A and C is actually the displacement. Now see, suppose I have a point P and a point Q. Okay. To go from point P to point Q, I can go like this also, right? I can go like this also. I can go like this also. Like I can go anywhere, right? I can go like this. I can go like this. I can go like this. But the shortest distance will be a straight line from P to Q. If I want to travel the shortest distance, it has to be a straight line. If I want to reach Q in the shortest possible path, it has to be a straight line. So please remember the shortest distance between any 2 points is always a straight line. You have to remember this fact, that shortest distance between any 2 points is always a straight line. So I started from point A. After some time, I'm at point C. See, initially I was at A. Right now I'm at C. The shortest distance between the initial point, that is A, and the final point, that is C, the shortest distance between these two is called as displacement. Okay, displacement. So actually, I'll actually tell you how to find this. So first, let me write what is displacement. It is the shortest distance. It is the shortest distance between the initial point, shortest distance between the initial point and the final point. Now let's see, how do we find this shortest distance in this particular example? Okay. See, whenever we have a right angled triangle, no? Whenever we have a right angled triangle, okay, we can apply something called as a Pythagoras theorem. Whenever we have a right angled triangle, okay, just straight line, okay. Let it be ABC. ABC is a right angled triangle. Let it be right angle at point B. All of you kindly switch on the video. It's my humble request. Okay. See, I have a right angle triangle ABC, a right angle at the point B. The side which is opposite to 90 degree, no, is called the hypotenuse. Some of you would have learned that hypotenuse means longest side. That is true, definitely true. But I have seen right angle triangle where two sides will look exactly same. You will not be able to decide which is the hypotenuse. You will not be able to decide. Yes. So always remember, right, hypotenuse means the side which is opposite to a 90 degree. That is the hypotenuse. So Pythagoras theorem states that in a right angle triangle, the square of the hypotenuse, see, hypotenuse is AC. So square of the hypotenuse is equal to the sum of the squares of the other two sides. That is AB square plus BC square. You measure this length, square it. You measure this length, square it. So sum of these squares of these two sides will be equal to the square of the hypotenuse. This is Pythagoras theorem. Now, if you look here, we have also got a right angle triangle, because this is a ground and I'm coming straight here. So this is a right angle. This is actually a right angle triangle ABC. So here also I can apply Pythagoras theorem. And if we apply Pythagoras theorem, what will be the Pythagoras theorem here? See, hypotenuse is AB here. So AB square is equal to AC square plus BC square. So AB is 5 square is equal to AC square is what? We don't know. AC we don't know. AC square, BC square is 3 square. So 5 square is 25. See, I'm going to take 3 square is 9 and bring it to the left side. So it will become minus 9. And that is equal to AC square. 25 minus 9 is 16. So I have got AC square is equal to 16. See, when I have A is equal to B, I can write B is equal to A also. So 16 is equal to AC square means I can write AC square is equal to 16. So what will be AC? AC will be plus or minus root of 16. See, generally people will not put this plus and minus, but you have to put this. I'll explain why. Whenever we are taking a square root, we have to put this plus and minus, okay? So AC will be plus and minus 4. That means AC can be plus 4 or minus 4. But here it is a length of a triangle, no? How it can be negative? So you write AC cannot be equal to minus 4. Therefore, AC is equal to 4. So that means AC is actually 4 kilometers. Now, why should we take this? Whenever you're taking a root, why should we take plus and minus? Let me explain that first. See, suppose I have x square is equal to 4. See, x can be 2. 2 square is 4. X can also be minus 2 because minus 2 square is also 4 only. Okay, minus 2 square means minus 2 into minus 2, minus into minus is plus, and 2 into 2 is 4. So minus 2 square is also 4 and 2 square is also 4. That means when I take a square root, I will get two answers. One is plus 2, another is minus 2. And when will we get that? Only if you put plus and minus root of 4. Then only you'll get plus and minus 2. Plus and minus 2 means plus 2 and minus 2. Both will come. And it is coming because square of negative number is also positive. Square of negative number is also positive. That is why whenever you're taking a square root, you should take both plus and minus. Now here, negative answer is not required. So generally in many books, they don't actually write this minus. But I request you to follow this technique of taking both plus and minus while taking root, because in 10th standard, there is a chapter called coordinate geometry where I have seen people not taking plus and minus, and that is why they get wrong answers. Because in coordinate geometry, no, we get coordinates, and coordinates can be negative also, positive also. If you see xy, x-axis, y-axis, we have negative and positive also, right? Everything is there. So that is why taking a root is always helpful, because when we go in higher classes, you will not make mistakes. Okay, so please do take plus and minus while taking a root. Very, very important. Okay, so here we have got the displacement to be 4 kilometer. So displacement here is, and what is the distance traveled here? 5 plus 3, that is 8 kilometers. Let's take another situation and understand distance and displacement. Okay, suppose I have a straight road. Okay, I have a straight road. This is a straight road. Okay, and I have some points here. Maybe this is P, and maybe this is Q, maybe this is R, maybe this is okay, I'll take only 4 points. Maybe this is S. Let this be PQ. Let this be 3 kilometers. Let this be 2 kilometers, and let this be 5 kilometers. So what I'm doing now, I'm actually starting from the point P. I'm going to Q. I'm buying something. It's actually a market, you can say. And I'm buying something, going to R. Then again buying something there, going to S. After buying something at S, I come back to R and I meet a friend here and I stop here itself. Okay. For some time, I'm stopping here. So what I'm doing, I repeat, I'm going starting from P, going to Q to buy something. After buying something at Q, I go to R, buy something there, go to S. And after buying something at S, I'm returning. While returning, I meet someone at S. While returning, I'm meeting someone at, sorry, R. Okay. So how is the motion here? I'm going from P to Q, Q to R, R to S, and S to R. In this motion, that is movement, what is the distance traveled? Can you all tell me? Just try. What is the distance traveled here? Just try. Going to P to Q, Q to R, R to S, S to R. What is the distance traveled in this particular scenario? All of you try. Very good, Roshan. Lokajit, please check. Lokajit, please check. Aditya, please check. Prince, okay, 1 minute. No. Only Only Roshan is right. Nobody else is right. Okay. Let's discuss. Let's actually discuss this. See, all of you listen. See, distance traveled means what? Total path length. Okay. Covered from the start to end. Okay. See, I'm traveling from P to Q first. So PQ plus QR plus RS plus again I'm returning back also, right? So SR. So PQ is 3 plus 2 plus 5 plus again 5. Okay, sorry. So you are right. Actually, okay, Roshan was not correct. Okay. So 3 plus 2 is 5, 5 plus 5, 10, 10 plus 5, 15 kilometers. Yes, okay, Roshan was not correct. I'm sorry. So distance traveled is 15 kilometers. So yes. So Prince, Aditya and Lokajit, all of you are right. Roshan, have you understood? Yes or no? Yes.
Yes, sir.
Very nice. Next, what will be the displacement here? All of you put in the chat. What will be the displacement here? Very good, Prince. Very good, Roshan. Yes, correct. I show you the definition of displacement here. Displacement is the shortest distance between the initial point and the final point. See here, while going from A to B, B to C, I was initially at A, now I'm at C. So shortest distance between the two is 4 kilometers, I found out. Here, tell me the answer here. No, locally check once again. It's not correct. Check once. So displacement is the shortest distance between the initial point and the final point. See, initially, I'm at P. I'm going to Q, going to R, going to S, coming back to R. So finally, I'm at R only, right? Initially, I'm at P and finally, I'm at R. So shortest distance between P and R is a straight line between P and R. Shortest distance between P and R will be a straight line between P and R. And that is what 3 plus 2, 5 kilometers. Lokajit, yes, you are right. Correct. So it is 5. Displacement here is 5 kilometers. Okay. Now let's take another situation. Okay. Let's take another situation. Okay. So now actually I'll erase few things here. Not some of the things are not required. Some of the things. So now the motion I'll change. Okay. The motion alone I'll change. Okay. Okay. Great. Okay. Let the point be like that itself. Okay. Point. Let it be just 1 minute. These are points, so it's okay. Let it be like this. Okay. So now my motion is something like this. See, I'm going from P to Q, Q to R, R to P to Q, Q to R, R to S. Then again R to S, I'm coming back, S to R, and then again coming from R to Q, and again coming back to P. So it's like R to, I'm going from P to Q, Q to R, R to S, S to R returning, and R to Q I'm returning, and then Q to P. That means I'm coming back to the same point. Okay. Basically, if you look here, I'm going P to Q, Q to R, R to S, and then R to S to R, R to Q, and Q to P. That is what is the motion. In this motion, can you calculate the distance and displacement, please? In the chat box, I'll put the answer in the chat box. All of you, please try. Good, Aditya, correct. Very good, Aditya. Nice. Yes, Prince, correct. Yes, Lokajit, very nice. Yes, Prince, correct. Check the spelling. Prince. Roshan. Look carefully, everyone. Look carefully. P to Q is 3 plus 2 plus 5, 10, and again 15, 17, and 20. So distance is what? Total path length covered by the object or the body. So that is 20. See, I'm not going to write PQ plus QR, all those things. It's 20. I have shown you actually on the screen itself. And what is the meaning of displacement? Shortest distance between the initial point and the final point. See, initially I'm starting from P and I'm coming back to P. That means there is no distance between the 2 points. I'm starting from here. I'm starting from P and coming back to P. So displacement is 0. So from here, we can conclude that displacement may be 0, but distance will never be 0 for any motion. From here, from all these examples, we can conclude that distance will never be 0, but displacement may be 0. And when will the displacement be 0? When the object comes back to the same point. When the starting point and the final point are same, then displacement will always be 0. Are you all getting or not getting? Yes or no? Yes. Fine. So here in the examples C, we have discussed straight line motion when the object is going in a straight line. Okay. What if any object is moving in a circular path? Let's calculate distance and displacement in those cases as well. Suppose I have a circular path like this. This is like a circular ground you can think of. So circular ground means circle will have a center, right? Let the center be O. Okay. Now, there is someone who is starting from point A. Okay. And finally, they're stopping at point B. Okay. There is a person who is starting from the point A and finally they're at point B. Let the radius of this circular ground, let the radius of the circular ground be 10 or maybe 2 kilometers. Okay, I'll take it as 2 kilometers. Let this radius of the circular ground be 2 kilometers. Okay. Can you all tell me? Just try, okay? Then I'll definitely solve. I will solve it for sure. But I want you all to try out. In this particular case, when the person is going from A to B, okay? So person is going from A to B means person will go like this only. Okay, look carefully, everyone. Person is going from A to B means circularly he is going like this. A to B. He's starting from A and going like this, like this, like this, and stopping at B. In this motion, can you tell me, just try, what is the distance traveled and what is the displacement? Try, just try. Or better, I'll take it as let's say I'll take it as 7 kilometers. Okay. Let this be 7 kilometers. It will be easy for you to do it. Okay. Let that be 7. Let the radius of the ground be 7 kilometers. Circular ground, 7 kilometers. Try. No, Aditya, check, 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 check. Okay, let me explain. I see people thinking. And all of you, please switch on video so that I can understand also. Okay. It's very difficult to actually get what you're doing. When the video is not switched on, it is very difficult for me to interpret. Okay. So please, all of you have your video switched on throughout the class. It will be easy for me. Okay. Now, Roshan, before we discuss this question, can you tell me what do you mean by perimeter?
The circumference of the circle.
No, no, I'm just asking perimeter. Like I didn't ask for circle. I'm just asking perimeter.
The boundary.
The length of the boundary of any actually any figure. The length of the boundary. For example, I have a rectangle. Suppose I have a rectangle. Let this be A, B, C, D. So perimeter of the rectangle is you measure AB, you measure BC, you measure CD, and you measure DA. That will be the perimeter. So perimeter of any figure is nothing but length of the boundary. Boundary length is called perimeter. Okay. Now let the length of the rectangle be L. Let the breadth of the rectangle be B. So this will also be B. This will also be L. So what will be the perimeter? Perimeter will be, you first add all the length, all the, what is it? AB plus BC is B plus L plus B. See, we are having 2L, right? L plus L is 2L and 2B also. So 2 you take common. So L plus B. So perimeter of the rectangle is what? 2 into L plus B. That is how this formula has come. The formula 2 into L plus B has come because of this concept. Okay? Now, in the case of a circle, suppose I have a circle. Let me draw a circle properly using these shapes which I have. Suppose I have a circle, okay? So circle will have a center. It will have a radius. Okay. I can put small r, capital R, that is totally up to you. I'm putting small r. I have a circle with center O and radius is r, small r. Okay. See, perimeter of a circle means what? The length of the boundary here. Now, perimeter of a circle, we give a special name, we say circumference. Whenever it is a circle, no, we don't say perimeter, we say circumference. Circumference and perimeter both are same, but in the case of a circle, we are giving a special name, circumference. Circumference of a circle means perimeter of a circle. Yes or no? Yes. Now, so circumference of a circle is 2 pi r. And whenever they don't actually ask, like whenever they don't give you the value of pi, you can take pi as 22 by 7. You can take 3.14 also, but try to use 22 by 7. Always. It's easy. Okay. So circumference of a circle is 2 pi r. Now, if you look carefully, the person has started from point A and now it is at point B. Okay. The person started from point A and now it is point B. So the person has traveled only half the perimeter, right? Or half the circumference. See, circumference means it is 2 pi r. Half of it is by 2. That means distance traveled will be pi r. Yes or no, everyone? Pi r, no? It will be pi r, just pi r. So pi is 22 by 7 and r is 7. 7 gets cancelled. Okay, okay. Aditya has given the correct answer here. 22 kilometer. And what will be the displacement? See, displacement is the shortest distance between the initial point and the final point. See, initial point is A, final point is B. Shortest distance is a straight line. Shortest is a straight line. Now, radius is 7. So, this will also be 7 only, right? Radius is 7 means this will also be 7. Because what is radius of a circle? Radius of a circle means the distance from the center to any point on the circumference. Any point on the circumference, the distance between the center to any point on the circumference is called radius. So displacement will be 14 kilometers because 7 plus 7 is 14. Yes or no, everyone? Very nice, Prince. Correct. It is correct. Good, Prince. Okay. So now, let's do few more questions here. We'll actually take some questions from NCRT and do it. So second question from the NCRT in-text questions. Okay, we'll solve it. It says a farmer moves along the boundary of a square field of side 10 meter in 40 seconds. So there is a square field. Okay. I have a square field. I'll name it as ABCD. Okay. You can start ABCD from anywhere. There's no rule and all that you have to start from here or here. Like there's no rule. Okay. So I have a square field of side 10 meter. Means every side is 10 only. Okay. 10, 10, 10. A farmer moves along the boundary of a square field of side 10 meter in 40 seconds. Just give me a minute. Okay. So now, suppose the farmer is starting from point A. So you can make farmer start from any point. I'm starting the farmer from point A. So farmer is going like this, like this, like this, like this. So a farmer moves along the boundary of a square field 10 meter in 40 seconds. Boundary means the entire like, okay. So the farmer moves the boundary of a square field in of 10 meter in 40 seconds. That means 40 meter. See, boundary means what? If you see 10 plus 10 plus 10 plus 10, 40 meter the farmer is covering in 40 seconds. If you understand that carefully. Okay. What will be the magnitude of displacement of the farmer at the end of 2 minutes and 20 seconds from this initial position? Okay. See, I'm assuming that the farmer starting from here, they want to know the displacement of the farmer at the end of 2 minutes and 20 seconds. Now, if you want to find the displacement, you should definitely know where the farmer is after 2 minutes 20 seconds. You should definitely know that. Then only you can find the displacement, right? Yes or no? You know the initial point, you don't know the final point. You want to know where is the final point. Okay. Now, we know that in 40 seconds, the farmer covers one round. Okay, because they have given. The farmer moves along the boundary, along the boundary. Okay, in 40 seconds. So in 1 second, how much the farmer will move? 1 by 40. How do I need this 1 by 40? It's very simple. See, suppose I'm getting 5 pence for rupees 50. Suppose I'm getting 5 pence for rupees 50. So 1 pen, what will be the cost? You can easily say 10 rupees, but it is 50 by 5. Okay, 50 by 5, which is 10 rupees. So same way, 40 seconds, one round. So 1 second, 1 by 40 round, 1 by 40th of a round. So this is given in minutes and seconds both. So I'll convert entirely to seconds. See, 1 minute is 60 seconds. So 2 minutes will be what? 120 seconds. So 2 minutes 20 seconds means 120 plus 20. 120 plus 20, that is 140 seconds. See, if you convert this to seconds, it will be 140 seconds because 2 minutes is 120 seconds and plus 20, that is 140 seconds. So 1 second, 140 of a round, it is actually the farmer is moving. So in 140 seconds, the farmer will move how much? 140 into 1 by 40. 0, 0 gets cancelled, 2 2s are 4, 2 7s are 14. That means what? 3.5 round. Okay. Just give it a try. See, the farmer is starting from here. This is 1 round. This is 2nd round. This is 3rd round. So half round will be till where? Half round will be till here only. Because if you come back, it will be 4 rounds, right? So half round will only be till C. Yes or no, everyone? Yes, very nice. So see, 3 rounds means if the farmer starts, just 1 minute, let me write round here. See, if the farmer starts from the point A, this is 1 round. 2nd round is, then 3rd, like 3 rounds over, and then 4th round will be up like 3.5 round will be up to the C point. That means after 140 seconds or 2 minutes 20 seconds, farmer will be somewhere here. Roshan, is that clear or not clear? Yes or no, Roshan?
Yes, sir.
Yes. Very nice. So initially the farmer is at A and finally the farmer is at C. Now we know that the displacement is the shortest distance between the initial point and the final point. So just join it. Just join a straight line between the two. And this will give me the displacement of the farmer. Now in the question, in the question, they have asked magnitude of displacement. See, magnitude means value of displacement. Now, why they have asked like they could have just asked displacement, right? Why they have mentioned specifically magnitude of displacement? Because we learn later on that displacement is a vector quantity. So it has got two things. One is the magnitude, another is the direction. Okay, it has got two things. One is the magnitude of displacement, another direction of displacement. Okay. Now, in the textbook, they have not talked about direction of displacement. That is why I didn't teach that. Okay. But for displacement, we have direction also. And that is why it is called a vector quantity. Displacement is basically a vector quantity. You will study scalar vector in your higher classes. Okay. So, magnitude is value of displacement. So, to find the value of displacement, we have to find this particular length, AC. And how do we find this particular length AC? If you look carefully, we have got a triangle here. If you look carefully, we have got a triangle here. A, B, and C is a triangle. And in mathematics, you have learned that in a square, each of the angles is 90 degree. Yes or no, everyone? In a square, each of the angles is 90 degree. So if this is 90 degree, the side opposite to that will be hypotenuse. This is hypotenuse. So I can apply Pythagoras theorem, and I'll get AC square is equal to AB square plus BC square. So AC square will be equal to 10 square plus 10 square. So AC square will be 100 plus 100. So AC square will be, see, 100 plus 100 is 200. So AC square will be, AC will be plus or minus root of 200. See, plus or minus root of 200, I can write 2 into 100 also, okay? And root of A into B, no, it is root of A into root of B. You please remember this fact, okay? Root of A into B is root of A into root of B. How do we know this? See, in mathematics, in 9th standard exponents, we have learned that if you have A, B, the whole power m, we have to give both the power m. A also power m, B power also power m. This is one of the rule in law of exponents, that if you have A into B, the whole power m, both will get the power m. Okay. So root means power is half. Last class itself I told you, last mathematics class also I've told you, root means power is half. So root of A into B is root of A into root of B. So here you'll get root of 2 into root of 100. So root of 100 is 10, and root 2 you cannot take out of the root, right? 2 you cannot take out of the root. So it will become plus or minus. See, for root of 100 we get 10, and 2 will remain inside the root because there is no pair for that, right? For 100, no, we have 10 into 10, right? So root of 100 is 10. Yes or no? Root of 100 is 10, but for 2 there is no pair, so it will remain inside the root. So AC is plus or minus 10, but AC cannot be negative, right? Because it is a length. Therefore, AC is only plus. AC is 10 root 2, it is meter. That means displacement of the farmer is 10 root 2 meter. Yes or no, everyone? Yes. Very nice. Okay. Just have a look. If you have some doubt, do let me know. We can discuss. Okay. Just have a look whether you're able to follow or not. Can you try this question? So first you go through this, and then I'll give you a question from the NCRT book back exercises. First you try this, okay? Just know, first you understand this, and then I'll give you the question. All of you just go through this. Understand. If you have some doubt, you let me know. So what we are doing, we are basically finding, first of all, the position finally where the farmer is after 2 minutes 20 seconds. For that, we use this rule. In 40 seconds, 1 round. So in 1 second, this much round. So 1 this much round. So by finding the number of rounds, we can locate where the person is. Okay. So you'll get it. Try this particular question. Friends, check. Displacement is correct, but distance is not correct. Yes, Prince, that is correct. We'll discuss. It's actually very easy. Okay, let's discuss. We'll give you 2 more minutes and then we'll discuss. Okay, let me discuss. All of you listen, stop writing. Just listen. You can practice the same question after the class also, okay? But now just listen. So an athlete completes one round of a circular track. So I have a circular track, let the center be O. So an athlete completes one round. One round means let this be the starting point. Okay. So one round of the circular track means what? One round means you start from here and come back. That is one round. One round means start from one point, take the complete circle and come back. This is one round. An athlete completes one round of a circular track of diameter. Diameter is given as 200. So that means radius will be what? 100 meters. Radius will be 100 meters. In 40 seconds, what will be the distance covered and the displacement at the end of 2 minutes and 20 seconds? See, if you want to find the displacement and the displacement, basically, you need the final point. So you should know after 2 minutes where the farmer will be. Okay. So distance also will calculate, but to find the displacement, we should know the final point for sure. So how to find the final point? Same way as we had done earlier. See, in 40 seconds, the farmer is completing one round. So in 1 second, the farmer will complete 1 by 40 of the round. 1 by 40 means somewhere here the farmer will be, maybe somewhere very close. So one round means like complete this one. 140 means somewhere here, maybe. We don't know where it is, but somewhere very closer to this. Okay. So 2 minutes 20 seconds means what? See, 2 minutes is 120 plus 20. That is 140 seconds. So in 140 seconds, farmer will be where? 140 into 1. So 1 by 140 into this one. To the 4. That means the farmer will take 3.5 round only. Okay. 3.5 round means what? 3.5 round means the farmer will start from here. This is 1 round, 2nd round, 3rd round, and half round means farmer will be at this point. Yes or no? That means after 3.5 round, the farmer will be at the point B. Roshan, understood or not? Yes.
Yes, sir.
So we have to find the distance covered and displacement. See, distance covered means what? Length of the path. So 3.5 round person is coming. Let's see, length of the path is this, plus again, plus again, plus again half. Okay. See, distance travel means total path which is covered, right? Total path is first 1 round, then another round, then another round, and then half round. So totally 3.5 round. Okay. See, for covering 1 round, how do we find distance? For covering 1 round, distance is 2 pi r. This is 1 round. But person is taking 3.5 round. So we'll just multiply 3.5 into 2 pi r. See, 1 round is 2 pi r. So 3.5 round will be 3.5 into 2 pi r, no? Yes or no? So we'll simplify this. So 3.5 into 2 into pi is 22 by 7. And what is r? R is 100. Okay. See, we have a 3.5 here. So I can write it as 35 by 10. Last class also I told you. Whenever we have one decimal, I can multiply the number with 10. So 3.5 is 35 by 10. And 35 by 10 is nothing but 3.5 only. Okay, you know that. So 2 into 22 by 7 into 100. 7 5 is 35. Okay, 10. Another 0 gets cancelled. Now you multiply. 5 2 is 10. And 10 into 22 is 210. Sorry. 10 into 22. And 1 0 is here also. Okay. There is 1 0 here also. So maybe actually I'll write clearly. It will be, otherwise it will be very confusing. So this is 100 and one of the 0 is getting cancelled. So 5 into 10 is 5 into 2 is 10. 10 into 22 is 220 plus 1 another into 10 is 2200. See, 5 into 2 into 22 into 10. 5 2 is 10 and 10 into 10 is 100. And 100 into this is 2200 meter. So the distance traveled is 2200 meters. Yes or no, everyone? And displacement of the farmer will be what? Displacement of the farmer is the shortest distance between the initial point and the final point. Initial point is this, final point is this, shortest is this. Shortest distance is the diameter actually. So displacement, sorry, let's reduce the size, it's actually very big. Why? Because initial point is A and final point is B, so it is the diameter. Clear or not clear, everyone? Yes? Fine, fine, fine. I'll give you few more questions. Okay. Now, before I give you a question, no, we'll learn one concept. Okay. Now, this particular concept is going to help you till your 12th standard. Okay. For sure. Okay. So, even in graduation, also it will help. So, listen to it very attentively. Okay. Now, so the concept which you are going to learn is unit conversion. Some of you may be knowing it. Okay. Some of you get confused at some times. It's okay. We'll learn it. Okay. Unit conversion. See, because we need unit conversion for this chapter. Okay. So I'm going to teach at the start itself. Okay. Unit conversion. Okay. So for the unit conversion, I will draw a ladder diagram. Okay. Ladder diagram will look something like this. These are the steps in the ladder. This is step 1, step 2, step 3. Okay. This is another step which I've drawn big. I'll tell you the reason why I've drawn this step as a very big one. Okay, this is another step. Okay, so here I have these steps. Okay. Now on each step, I will write something. So here I'll write milli, centi, deci. And here, no, I have the like base unit. Now, base unit may be anything. It may be meter or it may be liters. Okay. It may be grams. Okay. So here we have the base unit. Now, in this chapter, we are going to use only meters. So I'm going to put meter here. Okay. So this will become millimeter, centimeter, decimeter. If you put gram here, now it will become milligram, centigram, decigram. If you put liters here, it will become milliliter, centiliter, deciliter. Okay. So here I am putting meter because in this chapter we have only length and distance, all those things. Okay. So milli, centi, decimeter, and then we have deca, and then we have hecto, and then we have kilo. Okay. So you have to actually remember this order. Very, very important. This order is actually very important. Okay. Now, when we are converting units, either you'll be going, maybe actually let me erase this also. Actually, I'll write somewhere else. Okay. See, when we are actually converting units, either you will be going down or you will be going up. Like either you'll be going down like this. And when you are going down, now you'll go each step by step only, right? You'll go step by step. When you're climbing a ladder, you'll go step by step. Okay. And you may go up also, right? Like this. You may go up like this. So either you can go down or up. Okay. So suppose if I'm going up like this. So when we are going, either we can go up or down. Okay. And we'll always go step by step. Okay. We'll go step by step. Either you can go like this, like from here to here, from here to here. And then I will write properly. Okay. Okay. Now, whenever we multiply whenever we are going each step down, no, we have to multiply it by 10. Every step you go down, you have to multiply by 10. Every step you go down, we have to multiply it by 10. You have to remember this. Whenever we go each step down, we have to multiply by 10. And same way, when we are going every step up, see, up means you'll go like this. But actually, I will mark it this way. Okay, because it will be very confusing here if I write. But you understand, going up means we are going like this only, okay? But I'm writing this way, okay? So if you're going up, okay, if you're going up, we'll actually, okay, if you're going up like this, okay. So when you're going up, each step we are divided by 10. Each step we are divided by, this will help you till your 12th standard, so please listen to it thoroughly. I have seen my friends when I was studying in 11th and 12th, making a lot of mistakes in all these things, okay? Even I didn't know all these things. Just because I'm teaching, I have learned all these things. And I'm trying to simplify things for the students so that they don't have to struggle. Okay. So when we are going down, we have to multiply each step by 10. And when you're going up, we have to divide each step. Divide each step by 10. Now, see for meter, no? For meter, the short form which we are going to use is small m. Now, if meter is a base unit, so here we can have gram, here we can have liters also. If meter is a base unit, this will become millimeter. So milli is small m and meter is m. Milli is small m and meter is so mm. It will become millimeter. This will become centimeter. Okay, maybe I'll write it down. It will be easy. So here, let me write meter here. Meter. Millimeter means small, milli small m, meter is small m. Millimeter. Centimeter. Centi is small m, C, and meter. Centimeter. This is decimeter. Decimeter is dm. Decameter is da. Deca is da and meter is m. Decameter. Hectometer is hm. hm. And kilometer is km. So for each of them, now you have actually some short kilo, which short form is actually, maybe I'll write that also. Kilo, the short form is k, small k, okay, it is a small k, please remember that. Hecto is small h, deca is actually da, short form, meter is small m, deci is d, centi is c, and mill is m. Okay, so millimeter will be mm, milli is small m, and meter is also small m, so millimeter, centi, like that you should remember, okay. Now we'll be using this ladder diagram to do some conversions, okay. So let me use this one. Actually, let me take a copy of this. And we'll do some conversions, okay? Now, conversion is very helpful even in 10th standard. Actually, we have a chapter like surface area and volumes. There people, like generally in the exam, no, they will give different units and people will not be able to convert properly. We'll also learn how to convert area. Not only length, we'll also learn how to convert area. Like suppose if you want to convert meter square to millimeter square or millimeter square to meter square, you'll be able to do this using this ladder diagram also. Okay, let's do it. Look, suppose I want to convert meter to centimeter. I'm not saying how much meter, just meter to centimeter, just meter to centimeter. Okay, I want to convert meter to centimeter. See, meter is where here, centimeter is here. Okay, I want to convert meter to centimeter. See, meter to centimeter, if you look carefully, 1, 2. I'm taking 2 steps. So I have to multiply 10 into 10. See, 10 into 10 means what? 10 to the power 2, I can write, no? We have learned in exponents, 10 into 10 means 10 to the power 2. Because bases are same, I can add the powers. Okay. Suppose I do 10 into 10 into 10. I can write 10 to the power 3. 10 to the power 3 means 1000. And 10 to the power 2 means 100 also. I can see 10 to the power 2 means 1 followed by 2 zeros. 10 to the power 3 means 1 followed by 3 zeros. Suppose I multiply 10 into 10 into 10 into 10. That means 10 to the power 4. I can write. So just remember, whenever we are going down, no. If we are going 2 steps down, we'll put 10 to the power 2. Very simple. Okay. If we are going 2 steps down, we'll put 10 to the power 2. If you are going 4 steps down, we'll put 10 to the power 4. Yes or no, everyone? Because 4 steps you are going down, you're going to 10 into 10 into 10 4 times, right? So I'll put 10 to the power 4. If I'm going 6 steps down, I'll put 10 to the power 6. Suppose I want to convert, kilometer to millimeter. So kilometer to millimeter, I have to go 6 steps down. So I'll put 10 to the power 6. Very simple. I'll put 10 to the power 6. Now suppose the question is convert 5 meter to centimeter. Now 5 is a fixed number, right? So we'll just multiply 5 into 10 to the power 2. Okay. And 5 into 10 to the power 2 means what? 5 into 100, which is 500 centimeter. So 5 meter is 500 centimeter. Similarly, suppose I want to convert 7 kilometers into millimeters. So 7 into you do. Whatever constant is there, that directly multiply. Don't have to write this in expanded form because this is enough. 7 into 10 to the power 6 millimeter. So 7 kilometers, this much millimeter. Okay. Suppose I want to convert 14 centimeter to millimeter. Okay. See, 14 is a fixed number. So write 14 as it is into centimeter to millimeter. Centimeter to millimeter is only one jump. So 10 to the power 1. 10 to the power 1 means 10. So that means 14 centimeter is 140 millimeter. Are you all getting yes or no? It's actually very, very simple. Yes. Very nice. Now, here, like now we have seen examples where we are going down. What if we are going up? What will happen? Let's see that also. Okay, before I go to the next like thing, can you all tell me what will be 15 hectometer in meters? What 15 hectometers is how much meters? Can you put in the chat box? Fifteen hectometers is how much meters? Means right, Roshan, check. It is not correct, Roshan. 15 hectometers in meters. Aditya, check. Lokajit, no. See, if you look carefully, where is hectometers? Hectometer is here. Where is meter? Meter is here. Meter I told, okay. So hectometer to meter, one jump and two jump. There are two jumps. See, I told you for two jumps, put 10 to the power 2 because 10 into 10 you have to do, right? Whenever we are going down, we have to do 10 into 10. 10 into 10 means 100 or 10 to the power 2 is easy, right? And 15 is a constant. So 15 into 10 to the power 2. Yes or no, everyone? And 15 into 10 to the power 2 means 15 into 100. That means 1500 meter. So 15 hectometer is 1500 meters. Ganesh Puriyada, sorry, Roshan Puriyada. Yes, very nice. Sorry, next question. I'll ask here is, if you convert 15 meter to millimeter, what will be the answer? Roshan, excellent. Prince, excellent. Good. Ditya, very nice. बहुत अच्छा. Yes, Ritesh, it is correct. Lokajit, how did you put minus power and all here? See, meter to millimeter, okay? Meter is here, millimeter is here. So 1, 2, 3. We are going down only, right? So down 3 steps means 10 to the power 3. And 15 is there, so you just multiply. So 15 to 10 to the power 3 means 15 into 10 to the power 3 means 1 followed by 3 zeros. That means 15,000 millimeter. So 15 meter is 15,000 millimeter. Understood or not? Yes or no? No? See, whenever we are going down, we have to multiply each step by 10, right? See, meter is here, meter to millimeter, right? Meter is here, millimeter is here. So 1 step, 2 step, and 3 step. We are taking 3 steps, right? And down we are going, right? Down. So 3 steps down means each step we have to multiply by 10. Yes or no? So 3 steps we are going to 10 into 10 into 10. That means 10 to the power 3. Yes. And 15 is a number which is constant. So 15 into 10 to the power 3 millimeter. Yes or no? And 10 to the power 3 means 1000. And if you multiply this, you get 15,000 millimeter. Same thing I have done here. No, see, meter to centimeter. Meter is here, centimeter is here. So 2 steps. So 10 to the power 2 and 5 is a constant. So like that. Centimeter to millimeter, if you see here, 14 is a constant. So multiply 14 as it is. Centimeter to millimeter is only one jump. Only one jump. So 10 to the power 1. Yes or no? So whenever we are going down, no, power will be positive. Whenever we are going down, power will be positive. When we are going up, only power will be negative. I'll explain that. I have not explained that yet. Okay. So let me explain that next thing. See. Okay, before I explain like the next thing, see, whenever we are dividing any number by 10, suppose I am dividing 5 by 10. See, 5 by 10, can I write 5 into 1 by 10? Yes or no? I can write, no? 5 divided by 10 is 5 into. See, whenever we convert divide to multiply, we have to take reciprocal. Yes or no? So 5 divided by 10, I can write 5 into 1 by 10. Now in exponent, we have learned, 1 by a to the power m is what? A to the power minus m. Yes or no? 1 by a power m means it will be a to the power minus m. This is the law of x. This is a law. Okay, we have learned in the number system in maths. Okay, in exponents, we have learned 1 by a to the power m is a to the power minus m. So just remember, for example, I have 10 to the power 2. If 10 to the power 2 goes to the top, no, it will become 10 to the power minus 2. This is a rule actually. Suppose I have 10 to the power 3. If it goes to the top, no, it will become minus 3. So same way, here 10 to the power 1 is there. Nothing is there means 1 is there. So it will become 5 into 10 to the power minus 1. Yes or no? Yes or no? Now suppose I am dividing 5 by 100. Suppose I am dividing 5 by 100 or 15 by 100. So 15 into 1 by 100. And 1 by 100 means what? 10 to the power 2. 100 means 10 to the power 2, no? 10 to the power 2 means 1 followed by 2 zeros. And if you take 10 to the power 2 to the top, it will become minus 2. Okay. So just remember, dividing by 100 means into 10 to the power minus 2. Dividing by 10 means 10 to the power minus 1. Yes or no? Dividing by 1000 means 10 to the power minus 3. Yes or no? Multiplying by 10 to the power minus 3. Okay. So now, let's do the conversion. Suppose I want to convert 15 millimeter to meter. See, 15 is a constant, right, as it is, into, see, millimeter is here and meter is here. So we have to go up only, right? We cannot go down, we have to go up. Because millimeter to centimeter, we have to go. 1, 2, 3 steps you have to take. 3 steps means 10 to the power minus 3. 3 steps means 10 to the power minus 3. See, if you are going down, put positive power, how many steps you are taking? If you are going down, put positive power, like depending on how many steps you are taking. If you are going up, put negative power depending on how many steps you are going up. Yes or no, everyone? Yes, very nice. Next, similarly, if I have 45 centimeter and I want to convert to meter. So 45 is a constant into 10 to the power 2 steps you are going up, no? See, from centimeter to millimeter, there is only 2 steps. From centimeter to millimeter, there's only, sorry, so from centimeter to meter, there's only 2 steps. So 10 to the power minus 2. Okay. If you want to simplify this, okay, if you want to simplify this, we can do it also, okay. See, 10 to the power minus 2 means what? If you take to the bottom, it will become 10 to the power plus 2. Yes or no? If you take to the bottom, it will become plus 2. Yes or no? According to law of exponent, if it goes down, it will become plus. If it goes up, it will become minus. Like if this goes up, it will become minus. If it goes down, it will become plus. It's a rule. Okay. 1 by a to the power m is, if it goes up, it will become minus. And if I am having minus, if you take down, it will become plus, like this. Okay. Yes. So 45 by 10 to the power 2. 10 to the power 2 means what? What is 10 to the power 2? 1 followed by 2 zeros. Yes or no? So 45 by 100 means I can write 0.45, no? So 45 centimeter is 0.45 meter also we can write. Yes or no? Yes or no? So if you want to simplify, you can do it, but this is also fine. But when we are having smaller powers, no, it's better to simplify. Like if it is 10 to the power minus 6, you leave it. But 10 to the power minus 2, 10 to the power minus 1, do it. Like do put decimals, it will be easy. Even this one also we can do. 10 to the power minus 3 also we can do. How it will be? 15 divided by 10 to the power 3. 10 to the power 3 means 1000. That means 0.015 meter. Okay. 3 decimal places we have to put because 3 zeros, so 3 decimal places. Yes or no? Yes or no? Yes. So can you all try and tell me? I want the answer in decimals, okay? I want the answer in decimals. Okay, you have to tell the answer in decimals. Suppose I have 437 meters and I want to convert in kilometers, okay? I want the answer in decimals, okay? Do it. Very good, Roshan. And see, all of you, whichever topics looks difficult for you, if you have a confusion, you ask in class. Otherwise, you can also watch the recording. I'll post the recording in Google Classroom. You can watch the recording also once. If you want to understand better, if you want to actually have difficulty understanding, you watch it twice. It will definitely help. Aditya, Prince, Ritesh, very good. All of you, right? Okay, no problem, Lopajit will understand. Okay, at least like you have put some decimals, no problem. Let's discuss. Okay. See, 437 is a constant. So write that as is 437 into meter to kilometer. See, meter to kilometer, how many steps we are going? Meter to kilometer. Okay. So from meter, we have to start one step. So from meter to decameter, we'll go one step, then two step, and then three step. Only three steps are there, no? Yes or no? Yes. So 10 to the power minus 3 will come. So that means I can write 437 by 10 to the power 3. Because it goes down, it will become 10 to the power 3. Yes or no? See, 10 to the power 3 means 1 followed by 3 zeros. 1 followed by 3 zeros. That is the meaning of 10 to the power 3. 10 to the power 3 means 1 followed by 3 zeros. Okay. Now, how many decimals places will come? 3 because there are 3 zeros. Okay. So answer will become 0.437 kilometers. Clear? Yes or no? 3 decimal places will come, no? You have put 4 decimal places actually. Okay, so 437. If you want to learn how to put decimal places, if you have a confusion in that also, I'll tell you how to put decimal places. Okay, I'll tell you. Listen. All of you listen. See, suppose I have the number 15, okay? Can I write 15 as 15.0? Yes, because after point we have a 0 means like it will be still 15 only. Yes or no? So any number, for example, I have 7, I can put 7.0. If I have 100, I can put 100.0. If I have 157, I can put a 157.0. Any number, I can put a point and a 0. Yes or no? It will not change because after point we have a 0 only. So it doesn't matter. Yes or no? Yes. So suppose I have 15 by 10. Suppose I have 15 by 10. So in decimal places, how will I write? So 15, I can write 15.0 divided by 10. See, we have only we have only 1 0 after 1, right? Yes, only 1 0 is there. That means we have to shift one decimal to the left. So the decimal will actually shift to this point, right? So it will become 1.50. 1.50 is same as 1.5 basically. So 15 by 10 is 1.5. Suppose I have 437 by 1000. So 437 means I can write 437.0, no? Yes or no? By 1000. So 1000 is three zeros are there. So one decimal, second decimal, third decimal. So that means decimal will come here. And before this, there is no number. So I can put a 0 also, no problem. Yes or no? So it will become 0.437. Are you getting or not getting? Yes or no? Yes. Now I'll give one more example. Suppose I have 98, okay, 987 by 100. So I can write 987.0 by 100. So two decimal places because 2 zeros. So 1 and 2. So answer will become 9.87. Clear or not clear? Yes. Very simple. So can you all try and tell me? Okay. So can you all try and tell me what will be 469 centimeter in meters? I want answer in decimals. And all of you kindly keep your video switched on. It actually gives a good perspective whether you're able to understand or not. Okay. Your expression can tell a lot of things. It's easier for me to understand. Roshan, you use like two screens or just one screen? Like, do you have two screen?
Two screens, sir.
Okay, okay. Okay, Roshan. Okay. Yes, Ritesh, you are right. Yes, Aditya, you are right. Very good, Aditya. Nice. Very good, Prince. It is correct. Lokajit, very nice. Correct. Roshan, excellent. Let's discuss. All of you are right, but still I'll discuss. Okay. So we have 469 into centimeter, like 469 centimeters. So 469 is a constant. So right into centimeter to millimeter. So 1 and 2. We are going up only, right? Up. Centimeter to meter means we have to go up. So 2 times we are going up, right? So 10 to the power minus 2. See, 10 to the power minus 2 means what? If you take down, it will be 10 to the power plus 2. And 10 to the power plus 2 means what? 469 by 100. Because 10 to the power 2 means 1 followed by 2 zeros. Okay. So now we have to actually shift the decimal places to like 2 places, right? To the left. Look here. I have 469, so I can write 469.0 by 100, right? So 2 decimal places if you shift 1 and 2. So it will become 4.690. 4.690 is 4.69 only, okay? Or just remember 2 zeros, so 2 decimal places will come here. That's all. So 4.69 is the answer. Clear? 469 meters. Now we have learned how do we convert length. See, length is generally in meter and all, meter, centimeter, like that. Now, what if we have some area, like meter square and all, if you want to convert, let's see that, okay? That also is actually very simple only. Let me explain. Okay? Suppose I want to convert 25 meter square into centimeter square. 25 meter square into centimeter square. Suppose I want to convert this, okay? See, 25 is a constant, it's a fixed number. So write 25 as it is, okay? Into. See, whenever you want to convert area, first you convert the base, meter and centimeter. First you convert that, okay? Meter to centimeter. See, meter is here and centimeter is here. So one jump and two jump. And jump is down, right? Whenever jump is down, we'll put positive power, right? Yes or no? Whenever jump is down, we'll put positive power. So 10 to the power 2, because 2 jump we are taking to convert. Maybe I'll write in some other color. I'll write in this. No, than this. Okay, I'll write in this. 10 to the power 2, but I'll actually maybe put this color. See, 10 to the power 2 because meter to centimeter is 10 to the power 2. Yes or no? But it is meter square, right? So since it is a meter square, what you do is you put to the power 2 because it is a meter square. So meter you convert to centimeter first, then put power 2 because it's a square unit. You should not put square for this because this is a fixed number. You have to put square for that meter to centimeter. So 10 to the power 2 to the whole power 2. Yes or no? Now, in exponents, we have learned a to the power n, the whole power n is what? A to the power m into n. We have to actually multiply the powers. So here it will be 25 into 10 to the power 2 into 2 is 4, no? So 25 meters square is 25 into 10 to the power 4 centimeters square. Clear or not clear? Yes or no? Yes. Next. Next. Let me take another example. Suppose I want to convert 49 millimeters square to 49 millimeters square to meter square. Okay. See, 49 is a fixed number, no? So write as it is into. See, first you convert the base. Base is millimeter to meter. Millimeter is here, meter is here. So how many jump we have to take? 3 jump up. We have to go up. Up means negative power, right? Yes or no? Whenever you go up, we have to put negative power, right? So we have to put 10 to the power minus 3. But it is a millimeter square, no? So you have to put square for this. Are you getting or not getting? So answer is 49 into 10 to the power minus 3 into 2 is minus 6. So 49 millimeters square is this much. Suppose I want to convert Suppose I want to convert 487 kilometers square to meter square. See, first you write 487 as a constant. In kilometer to meter is 3 jump down, 3 jump. Kilometer to meter is 3 jump down. So 10 to the power 3 and the whole square for this because it is a kilometer square. So 487 into 10 to the power 6. Are you all getting yes or no? Yes or no, everyone? It's actually very, very simple. It's actually very, very helpful as well. Even in actually 10th standard, 12th standard, graduation, everywhere it is very helpful. Many people don't know how to convert itself actually. Okay. But it's actually very simple. Okay. So can you all tell me the answer for this question? Suppose I want to convert 1287 millimeters square to centimeter square. I want answer in decimals, okay? Try. Just try. I want 1287 millimeter square to centimeter square. Just try. I'll come in a minute, okay? Let me see 1 minute. 1 minute we'll discuss. Okay. No. Ritesh, you are right actually. We'll discuss. Let me discuss. It's actually very simple. All of you look. Don't try anything. Just listen, okay? All of you listen. See, 1287 is a constant. Write as it is, okay? Now, into millimeter to centimeter. How many jump? Millimeter is here, centimeter is here. Only one jump, right? And up, we are jumping up. So 10 to the power minus 1 will come. Because only one jump and it is going up. So minus 1. And because it is a millimeter square, we have to actually put a square for this. So it is 1287 into 10 to the power minus 2. Because minus 1 into 2 is minus 2. Yes or no? Yes or no? Now, when minus 2 goes to the bottom, it will become 10 to the power plus 2. And 10 to the power plus 2 means 1287 by 100. Okay. And 100 means power, we have to actually shift like this. 1 and 2. See, this is 0.0 and 1, 2. So it will actually become 12.87. Are you all getting or not getting? It's actually very easy. Oh, look at it. You are right anyway. Very nice. Prince, you are right. Roshan Puriyada, are you getting? Yes or no? Roshan?
Yes, sir.
Puriyada, are you? Yes, very nice. Can you all try to convert? And all of you, I repeat again, actually every class I'm telling the same thing. Keep your video switched on. Like then only I can understand, okay, what is going on inside. Like at least some idea I'll definitely get, okay. When the video is switched on, I can get some idea. For sure, I can get some idea. But if the video is not switched on, I will not get any idea. Whether you're able to understand or not, I will not get any idea. So please keep your video switched on throughout the class, okay. Now, can you try to convert 587 decimeter, DM is decimeter, decimeter to meter. Oh, so decimal is square, okay? Because we're doing area, so I want in decimals, okay? Good, Ritesh. Correct. Yes, Prince, correct. Aditya, very good. See, if it's taking time for you, no problem. Spend some more time. Like, I mean, at home, you do all this, like, do a lot of questions, do a lot of practice. Definitely things will become easy. That is the only way out, okay? There's no shortcut to success, okay? There is no shortcut to success. We all have to put some amount of time to learn some concepts, okay? So spend more time. Lokajit, Roshan, both of you are right. Very good. Let's do this. We'll also do it actually here. So which is 587 is a constant, so write as it is into 10 to the power, see, decimeter to meter. Decimeter to meter is 10 to the power minus 1 because we're going up. And to the power 2 because it is this area. So 587 into 10 to the power minus 2. So 587 by 100, that means 5.87 meters. This is the answer. Now, if it is volume, because sometimes we need volumes also, right? In sufficient volumes, we have this conversion for sure, okay? So you should know how to convert volumes also, and you will be able to do it. I'm very sure. Let me give you a question. Suppose I want to convert 8972 centimeter cube to meter cube. Tell me the answer in decimals. No, Roshan, it is not correct. Check. It is cubic unit. Please be very careful. बहुत अच्छा रितेश. Very good. Look at the numbers also. Numbers maybe you are not written properly. Prince, it is correct. Roshan, no, Roshan still there is a mistake. Aditya, check. Prince, it is correct. We'll wait. And Ritesh, look at your number which you have given. The number which I have written is something else. Whatever you have written is something else. Just check. Look at the chat box. So be careful, okay? No problem, but be careful. That's it. So let's discuss. It's actually very easy. All of you listen. So we have 8972. See, centimeter to, listen. Centimeter to meter is jumping to upwards, to jump upwards. So upward jump means -2. Upward jump means 10 to the power -2 and to the power 3 because it is a cubic, right? See, always first of all convert the base. Always first of all convert the base. So centimeter to meter is to jump up. So 10 to the power -2 and to the power 3 because it is a cubic. So 8972 into 10 to the power -6. And -6 means what? If it goes down, it will become 10 to the power +6. And I wanted the answer in decimals, right? So 8972. 10 to the power 6 means 1 and 6 zeros. Correct? Now we have to shift the decimal to 6 places left. This is 0.0. See, 1 decimal, 2nd decimal, 3rd decimal, 4th. Now nothing else is there, no? So 5th decimal, 6th decimal. So since nothing is there, I can put 0, 0 here. And decimal will come here. Decimal point will come here. So we can put 0 before that. So answer is 0.008972 meter cube. Okay, let me explain through another example. You'll get more clarity. See, suppose I have 72 by 1000 or maybe 78 by 1000. So 78 by 1000 is 78.0 by 1000. So 3 decimal places, right? So 1, 2. Nothing is there, you go one more thing and add a 0 here. So it will become 0.078. 3 zeros, so 3 decimal places should be there, no? Yes or no? So same thing I have done here also. Clear or not clear? Yes, very good. So can you all try and tell me what will be the answer to this question? Suppose if I have 198754 millimeter cube to decimeter cube. Do it. I will come try. Okay, I'll come. Okay, all of it. Okay, 1 minute. Prince right. Aditya not right. Ritesh right. Roshan right. Lokajit check. Check once again. Lokajit and Aditya, try once again, then we'll discuss. I want both of you to try once again. Yes, both of you right. 1 minute, we'll discuss. Both of you right. Well. Okay. So all of you are right. So let's discuss. See, anyway, all these things is not required for physics of 9th standard. But still, I'm teaching you because we are not learning just to pass an exam. Should actually help. It should be very helpful for us till higher levels. Okay. That is why I'm teaching all those things. Okay. If you want, actually, I can just finish, like, teach whatever is required, but I'm teaching you extra things so that it's easy for you overall. So fine. So this is a constant, so I write as it is. Maybe I'll write here. So 198754 into millimeter to decimeter. Millimeter is here, decimeter is here. So 2 jump up, 2 jump up. So 10 to the power minus 2. It is cubic to the power 3. So 198754 into 10 to the power minus 6. 10 to the power minus 6, if it goes to the bottom, it will become 10 to the power 6. 198754, if it goes to the 10 to the power 6 means 1 followed by 6 zeros. Okay. And if you shift the decimal, 1, 2, 3, 4, 5, 6, that means it will come here only. And nothing is there before this means you can put a 0. See, before decimal point, if you put a 0, no problem. Okay. It looks good actually. So 0.198754. All of you have understood? Yes or no? Yes. Very nice. Now we are going to discuss few more things. Okay. Which will be requiring in this chapter. How do we convert speed? Suppose they have given 72 kilometer per hour and they want the answer in meter per second. How do we convert this? Okay, we'll be learning that actually. Okay. Can you all tell me, just give it a try, okay? Can you all tell me 54 kilometer per hour and I have okay, I have 15 meter per second. Which is greater out of these two? Oh, just give it a try. Which is greater? 54 kilometer per hour or 15 meter per second, which is greater? Okay. Aditya says it is 15 meter per second. Roshan says it is 15 meter per second. Ritesh says something. Okay. So see, this is A, this is B. Okay. Which of the two is greater, A or B? Okay. Lokajit says it is 15 meter per second. Prince, what do you think? Which is greater? Okay. Prince thinks it is again 15 meter per second. Actually, both are same. Now, why you made a mistake? Because you are actually comparing two things which are different, which are having different units. One is kilometer per hour, and another is meter per second. So here hereafter remember a rule. Whenever you're comparing two things, first of all, make the unit same. Always. Whenever you're comparing two things, make the unit same. Then only you have to go for comparison. Yes or no? Yes? Fine. So that is what we are going to learn. How do we convert it to make the unit same? So I want to convert 72 kilometer per hour into meter per second. So otherwise I'll take 54 itself, okay? I will take 54 kilometer per hour and I'll convert that into meter per second. So look at the rule. How do we do it? See, 54 kilometer per hour. I can write 54 kilometer by hour because kilometer per hour, no? So 54 kilometer per hour. So I can write 54 kilometer by hour. I want to convert to what? Meter per second. See, 54 is a constant, right? So write that as it is. Put a into. Okay. Now, numerator. That means I have to convert kilometer to meter. That means I have to convert kilometer to meter and hours to seconds. Hours to seconds. Okay. So it will become, see, when you convert kilometer to meter, we have already learned kilometer to meter. So 3 jump down, 10 to the power 3. 10 to the power 3 means 1 followed by 3 zeros. Kilometer to meter is 3 jump down. You have to remember the ladder diagram. And hours to seconds. See, 1 hour is 60 minutes. And 1 minute is 60 seconds. So 1 hour will be 60 into 60 seconds. Yes or no, everyone? Yes or no? So if you want to convert hours to minutes, see, 1 hour is 60 minutes and 1 minute is 60 seconds. So 60 minutes will be what? See, suppose I have 1 pen for 10 rupees. So 60 pens I will multiply 60 into 10, right? So same thing, 1 minute, 60 seconds. So 60 minutes will be 60 into 60 seconds. Yes or no, everyone? And 60 minutes is 1 hour. So 1 hour is this much seconds. Okay. So 60 into 60. So 1 0 gets cancelled, 1 0 gets cancelled here. 6 9s are okay. Now 3 2s are 6, 3 3s are 9, and 2 5s are 10, and 5 into 3 is 15. So it is 15 meter per second. That means 54 kilometer per hour is 15 meter per second. Yes or no, everyone? Yes. Let us do a few more questions. We'll get more confidence. Suppose I have 72 kilometer per hour, or maybe I'll take 90. I will take 90 kilometer per hour and I want to convert it into meter per second. Okay. So how do we do it? You can write 90 kilometer by hour. And if you convert 90 as it is, okay, into, and then meter per second we want to convert, right? So kilometer to meter is what? 1000 by hours to second is 3600. Because 60 into 60 is what? 6 6 is 36 and add 2 zeros. Double zero gets, that is how 3600 came. So 1 hour is 3600 seconds. Okay, remember that. Now look carefully. I can convert with 9. See, 9 itself I'll do it. See, 9 tens are, 9 fours are, okay, 2 twos are, and 2 fives are, and 2 fives are. So answer is 25 meter per second. Are you all getting yes or no? Can you all convert 72 kilometer per hour into meter per second? Do it. Let me explain. Lokajit, Prince, and Ritesh. All the three of you were right. Very nice. Let me explain once again. I have 72 kilometer per hour. 2 meter per second. Okay. 72 is a fixed number. Okay. Write that as it is. Put into. Now, kilometer you have to convert to meter because top you will convert kilometer to meter. See, kilometer to meter, if you want to convert, if you see the ladder diagram, Okay. Kilometer to meter, if you want to convert, 3 jump you have to take. 1, 2, 3. So 10 to the power 3 is 1000, right? 10 to the power 3 means 1 followed by 3 zeros. That means 1000. So kilometer to meter is 1000. Hours into seconds is 3600. 1 hour has 3600 seconds. You have to remember this. 3600 seconds. So double zero gets cancelled. And 36 twice is 72. And 2 into 10 is 20. So answer is 20 meter per second. Roshan, courier da, are you able to get yes or no? Aditya, have you understood yes or no? Aditya, have you understood yes or no? See, 1 hour has got 60 minutes. Okay. And 1 minute has got 60 seconds. So 60 minute will have 60 into 60 seconds. So 1 hour has 3600 seconds. So hours, when you convert to seconds, it is actually into 3600. Okay. So that is how it is. Okay. Next, suppose I want to convert this one. See, we'll actually give me 5 more minutes, 5 to 10 minutes. Okay. We'll end the class after this. Okay. Please be there. Okay. Now, suppose I want to convert okay. See, all of you know that speed is equal to distance by time, right? All of you know speed is equal to distance by time. All of you know this. Speed is equal to distance by time. Okay. Suppose. So we know speed is equal to distance by time. We know this. Suppose distance is in kilometer and time is in hours. So speed will become kilometer per hour, right? If distance is in kilometer and speed time is in hours, it will become kilometer per hour. Yes or no? Yes. Same way, if distance is in meter and time is in seconds, it will become meter per second. Okay. So the question is like this, or maybe I will still convert this. Okay, just 1 minute. I'll convert this. Just give me a minute. I'll give you the question. Okay, just in the simple form, I'll give you. Okay, yeah, it's easy. Okay. Suppose I have 0.6, okay, 0.6 kilometer per minute, okay. Can you convert this into centimeter per second? Please do it. Convert 0.6 kilometer per minute into centimeter per second. Do it. Try. We'll also do it. First you try. Try and then we'll do it. All of you listen. You stop writing, just listen. I want to convert 0.6 kilometer per minute. So I'm writing like 0.6 kilometer per minute. I want to convert to centimeter per second. Okay. Okay. So now 0.6 is a constant, write as it is. Okay. Into kilometer to centimeter. If you convert kilometer to centimeter, how many jumps you have to take? Look at the table here. Kilometer to centimeter, you have to take 5 jumps. Yes or no? 5 jumps you have to take, right? 5 jumps. So 10 to the power 5 will come, no? 10 to the power 5 will come. 10 to the power 5 means 1 and 5 zeros. Divided by minute to seconds. 1 minute is 60 seconds. 1 minute is 60 seconds, correct? Yes. Now, see 1010 gets cancelled. See 0.6 means 6 by 10 because 1 decimal, so I'll put 10 in the denominator. Into, see here we have got 1 and 4 zeros because 1 0 got cancelled and by 6. 6 gets cancelled and 1 0 gets cancelled. So answer is 1000 centimeter per second. Clear or not clear, everyone? It's actually very simple. I have followed the same steps. Yes or no, everyone? Lokajit, understand? Yes? No? No problem. See, we have 0.6. We have 0.6 kilometer per minute. I want to convert to centimeter per second. See, 0.6 you write as it is. Okay. Now, kilometer you convert to centimeter. See, if you convert kilometer to centimeter, if you see the ladder diagram, it will be 10 to the power 5. Because you're jumping from kilo. Kilo is up and centimeter is down. You will jump 5 steps. So 10 to the power 5 you have to put. 10 to the power 5 means 1 and 5 zeros. Clear? 1 minute. See, minute, if you convert minute to seconds, it is 60. 1 minute is 60 seconds. Yes or no? Yes or no? So I write 60 here. And then it's simple simplification. 1 0 gets cancelled. 0.6. See, 0.6 means what? 6 by 10 only, right? So I wrote 6 by 10. And see, because 1 0 got cancelled, I wrote this by 6. Now 6 got cancelled. And 1 0 here got cancelled. So we got left 1000. So answer is 1000 centimeter per second. Yes, sir. Can you all try to convert this 1 minute? Can you try to convert the same thing? Same thing you convert to another unit, meter per second. Same thing you convert. This is the question. And I want in meter per second. Like, I mean, so the question is like 0.6. Maybe I'll go to the next page and write. So the question is 0.6 kilometer per minute. You convert it into meter per second. Do it. The page was right that time. Nice. See, please practice all these things because we'll be requiring in the chapter, and I will not teach all these things again. I will not teach all this because it will be required in the chapter for sure. Because sometimes they'll ask average speed in meter per second, sometimes they'll ask in kilometer per hour, sometimes they'll ask in centimeter per second. All these things they will ask. Very good, Prince. No, Roshan, check. Okay, Roshan, maybe you have answered. Please, I don't know which question you have answered. Hitesh, good. No, Dokuji, that is not correct. Let us do it. So we have 0.6 kilometer per minute. And I want to convert to meter per second. Okay. So 0.6 right as it is. See, Lokajit, if you convert kilometer to meter, what have you, like, do we have to multiply with which number? Kilometer meter is 10 to the power 3, that is 1000. Yes or no? Yes, 1000. And the minute to seconds, that is 60, right? Because 1 minute has got 60 seconds. Yes or no? So 60. Now 0.6 can I add 6 by 10? Yes or no? And 1000 by 60. 1 0 gets cancelled, another 0 gets cancelled here. 6 gets cancelled here. We are left with 10 only, right? So answer is 10 meter per second. Clear or not clear? Understood or not? It's actually, see, calculation only you have to do properly. That's all. Roshan, Puriya da Roshan.
Yes, sir.
So next question, I am very sure everyone will get it correct. Roshan, please keep your video switched on. So 0.6 kilometer per minute. I want to convert it to kilometer per hour. Please try everyone, and I want everybody to get it correct. Do it, everyone. No. All of you try. Look at it. Very nice here. Awesome. Very good. Roshan, you also try. I don't know, like, what is happening. Like, just try. It's actually very easy only. Just try once again. Like, whatever methods we have followed, if you do it, it will be easy. Okay. One thing I liked about Lokajit is actually is very straightforward, open. Like, yes, he's not able to follow or he's able to follow. So everyone should be like that. If you're not able to follow, you can be very straightforward. No, but you after that you have to focus also. Some people I have seen some students, no, they'll say every time they will say not understand, not understand. Actually, every time they will say like that. Prince, you are not correct. So every time they will say like that only, but they will not focus. So if you're like that, I cannot help you out for sure. You have to focus. I understand that some things it will take time for you to understand, but you have to be focused also at the same time, everyone. Okay, all of you listen. I'll explain this last question and with this we'll stop. Okay, we'll not do any more questions hereafter. This is the last question we are doing. So look carefully. So 0.6 kilometer per minute, and I want to convert kilo into kilometer per hour. Okay. See, 0.6 is a constant. Now, kilometer to kilometer. Now, so see, we don't have to do any jump, right? So you can say it is just one. So kilometer to kilometer just one, or just leave it because it's the same unit. We don't have to convert the unit itself. So kilometer is kilometer. Yes or no, Roshan? Now, so top is you can keep one itself because like nothing is there means one we can keep, no problem. Denominator, minute to hour is what? See, 1 hour is 60 minutes. Okay. So from here, can I say 60 minute? 60 minute is 1 hour. But here we don't have 60 minutes. We have only 1 minute. Nothing is there means only 1 minute. So if you convert minute to hours, it will be 1 by 60 hour. Yes or no? 1 minute is 1 by 60 hour. Yes or no? So we have to write by 1 by 60. Yes or no, everyone? If you convert minutes to hour, it is 1 by 60 of hour. Okay. Now, 0.6 is 6 by 10. And 1 by 1 by 60 is into 60. See, 1 divided by 1 by 60 is 1 into 60 by 1, which is 60. So I got 60 here. So 0 gets cancelled. Answer is 36 kilometer per hour. So answer is 36 kilometer per hour. Are you all getting? Yes or no? Roshan, Priyada, are you getting? Priyada? Yes. Okay. Prince, you understood? Yes. We'll stop with this. If you have some doubt, please do it and ask. If you don't have a doubt, you can leave. Thank you so much, everyone, for joining in. Take care. Bye-bye and have a great evening.
Thank you, sir.
Welcome. 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 Welcome.